All right. So let me, so in the last one, in the end, we had to find a radius of convergence, and it ended up being infinity. So I would like to do another radius of convergence problem where it isn't infinity. Um, this one, there's no differential equation involved in this. I just wanted, and this is kind of like review from Calc 2. I just wanted to do an example because, I know that people generally, find this hard and need a review of it. Um, so let's find this radius of convergence. Um, we start by finding this L, which is the limit, the absolute value of the n plus 1th term over the nth term like that. And I have a fraction divided by another fraction, so I flip the bottom. Like that. I see some stuff that I can cancel. I have 2 to the n and 2 to the n plus 1. So there's just a 2 left over on the bottom. I also have x to the n and x to the n plus 1, so there's just an x left on top. So where am I now? I've got this stuff, an x on the top and a 2 on the bottom, and then there were some things that didn't cancel yet, like this n and this n plus 1. So this is what I've got. As n goes to infinity, though, this limit is just 1, right? So I've got x over 2. So what do we know about the ratio test? This converges, or the series converges if L is less than 1, and diverges if this is greater than 1. It may converge or diverge if this equals 1, but for our purposes here, we don't worry about when L equals 1. What this means is, for example, I can say the following. The series can only converge if this is less than or equal to 1, because it might converge even if this does equal 1. It definitely converges if it's less than 1. So I guess that would be absolute value of x is less than or equal to 2. So, and yeah, I don't really fully get into the theory of this in this class, but we have the interval of convergence, and I'm not sure what happens when x is exactly -2 or exactly 2. To do that, we would have to think harder and examine it further, but we don't need to do that just for the radius. The radius is just half the length of this interval, or if you like, the radius is just this number. Right, like why do we call this the radius? Because it's sort of like it's centered at 0, and the radius is like how far out in each direction does it go. That's why we call it the radius. In any case, it's just this number. So that's a radius of convergence that is not infinity. So that's what happens.